Introduction, I'm sorry. So, we'll make it quick. Do I really need to introduce the keynote? I'm not sure there is even 10 people in the room who don't know Fernando. I'm still gonna say, and I need some notes to remember everything that Fernando has done. And actually, I will not say the whole list. But so Fernando is a research scientist at UC Berkeley. He works in neuroimaging. He's obviously also the author, original author and lead developer on IPython that probably all of you use every time you want to do anything in Python. So you should thank him for that. He has received in 2012 a really awesome award, which is the Award for Advancement for Free Software by the Free Software Foundation, after big names like Guido and people in GNU Linux and so on and so forth. So it's a really cool award, and he deserves it by all means. Him and IPython also just got a really nice grant from the Sloan, Alfred P. Sloan Foundation to make IPython even cooler than it is already. I know it's hard to imagine, but I think he's going to help you imagine how it's going to be. Finally, obviously, Fernando has been a really long time Python advocate and pillar for this community. We're really excited to have him as a keynote this morning. He has been a community organizer. He has been one of the founding board members of this new NumFocus organization that's trying to push even harder behind NumPy and all the packages around. So, and Andy was mentioning about the French connection at this conference, and he even speaks French fluently. So he fitted perfectly for the keynote. Seriously, he has been pushing for more than a decade for science to be done better and to be more easily reproduced. And so it's really exciting to have him kick off this conference and tell us a little bit more about reproducibility. Thank you.
Thank you, Jonathan, for that very nice introduction. It's really a pleasure to be here. As Jonathan said, I've been sort of playing this game for a while now. It's getting to be a long time, and this is in many ways home. I can really echo the comments that were made earlier about this conference being one of the most. Let me get things ready here. About this conference being really one of the most fun and enjoyable places to be at, where most of us come from some community, some academic typically or industrial community, which has its own sort of turf wars and battles and dysfunctionalities. And it seems like this is a space where a lot of the good stuff happens and less of that happens. And I know that I've heard many of our friends over the last 10 years say that about this conference. But what's really good to see and what I'm really thrilled to see is that it's not only those old faces from 10 years ago. Some of us are still here, but there really is a lot. There are really a lot of new faces, and what I hope is that all of this new blood will retain the quality and the spirit of this community, but will bring lots of new talent, new ideas, and new directions for us to grow in. Let's get going on trying to explain what it is that IPython is and does, and how actually, despite the fact that it is something that appears discombobulated and big and messy and without a very clear purpose, that there is a method behind the madness. We actually think very hard about what we're doing. And this is a serious case of dog fooding. The slides are actually a live notebook that's been running for a couple of days, and where there's actual computing on the inside. And you'll see why I'm trying to do this, despite the fact that it kept me up until 6 in the morning. Probably this quote that I first read when I arrived for my PhD in grad school at CU Boulder on the door of my advisor from Hamming is probably what best condenses. And by the way, who's keeping time? I'd like a 10 and a 5. Okay. Probably condenses best what we're trying to do with IPython, which is to build tools that help us extract genuine insight out of computational processes. And that is very much in line with the spirit of trying to make science fundamentally a communicable and reproducible endeavor, and not simply something that ticks checkboxes for papers and people's CVs. In a very schematic way, this is how I've been framing this conversation lately, because I find that it helps, even though it is a bit of a cartoon description, but I think it helps organize sort of how we think about IPython in terms of the sort of the life cycle of what a lot of us actually do in practice. And of course, pieces are missing, and real life is messier than something like this. But I think to a first approximation, it's not a completely unfair way to describe how we work. We explore ideas on our own. We play with code. We play with data. We play with an algorithm, a paper we've read. At some point, we try to engage our colleagues because we want their expertise, because we want their data, because we want their ideas. Often we end up having to run, if these ideas are going somewhere, we have to run them in a production setting. These days, that typically will mean either HPC, classic HPC environments or cloud environments. If things go well, we may publish these our results, and I mean the word publish in a very broad sense. You may be writing a paper, but you may be writing a technical blog, you may be writing a book, you may be communicating to your clients, to your customers, right? Publishing is, what I mean by publish is to communicate your ideas. But it's important, I think, that this publication is one where you can trust that what is being communicated actually is what happened in the computation, and that you can replicate what happened and that others can build upon it. And finally, we educate. We communicate, especially in science and academia, we have to train from these ideas the next generation of students who come, the next generation of scientists who come after us. And typically we just keep looping like hamsters in this wheel. And for all of this to happen fluidly, and very particularly for our outcomes to be really reproducible, it's imperative that we can move back and forth, not just forward, not just simply get something, copy and paste it into a paper, then copy and paste it into a PowerPoint and move forward, but that we can actually move fluidly back and forth. So that if when we are writing up a paper, a question comes up, we should be able to move backwards easily on using the same tools to replicate and reproduce what we're doing. And today's tools tend to make this fluid movement rather difficult. And so we've tried to build IPython to basically provide an environment where all of these things can be done, and can be done fluidly and easily. It all began a long, long time ago, longer than I care to admit. This is where the fun begins, because I'm actually going to run code, and we'll see if I have a network connection. Yes, I do. So this is actually IPython 001. In all of its, let's turn on line numbers. In all of its 250 line glory. That was the end of IPython 0.1 as it was written sometime in October or November of 2001, when I was trying to find an excuse not to finish my dissertation. You will find here the very sophisticated configuration system that it had, but you'll recognize our old friends Numeric, which is now NumPy, GNUplot and Graceplot, which we've abandoned because now we have Matplotlib, a hackish set of unit stuff that now we have much better unit machinery, but the cache and the numbered prompts and the basic ideas that we have today in IPython were there in these 259 lines of code, despite the fact that now I think we're at like 150,000 and counting. So we go from, the title of the talk was from the shell to a book, and it all began at the shell, and those 259 lines of code tried to provide a shell that was better than the default Python shell, where you could do things like run code and get decent error messages and move around the file system. Then over time, we were able to add, and this is how Matplotlib was born. John Hunter and I basically started digging into integrating the two, and we were able to add the ability to have live interactive plotting while we were working at the shell. Then Min Reagan-Kelly, who was a graduate student of Brian Granger. Brian is my very, very long-time friend and collaborator. We met in grad school. He was one of the first people that I met the first day in grad school back in Colorado. Min was one of his students at Santa Clara who was going to do an undergraduate thesis, senior thesis project in parallel computing. And he ended up adding interactive parallel computing support to IPython, which to us made a lot of sense, to Brian and I, even though to a lot of people it didn't. At some point, we had a version of it that was using Twisted, and where we collaborated with Michel Sander and Jose Pinco and others on building around the vision system that some of you may remember from some of the old SciPy conferences of the day. To add interactive parallel computing. Later, with the support of Enthought and lots of work by Gaël Varocco, who's in the room, and Laurent Dufréchou, two from the Python French connection, IPython was integrated into tools like Mayavi so that you could have interactivity, but not in a command line interactivity, but embedded in an application that is a graphical application. In this case, this was Mayavi. And then, over time, we got, in 2000, and I'm drastically condensing here, obviously, the history of what happened, but in 2010, Evan Patterson, thanks to critically important support from Enthought, because this support came at a very, very key juncture, Evan Patterson began to work on writing a new kind of shell for IPython while Enthought supported Brian and me in the background to basically build the architecture that made this possible. And this was a really important moment for us because enabling this to give us a shell that looked kind of like a terminal at first blush, but where you could run code kind of like in the normal terminal, and yet that code could do things like produce inline figures and whatnot. Turns out that it was not just a very useful tool in its own right, but it actually was the time when we created the architecture that made the rest of what's coming possible. This, by the way, is a tool that is connected. That is the figure that I created in the Qt console, which is available here. This Qt console was just opened against the same exact kernel that is running here in this notebook. I can keep multiple objects communicating with the same computational backend at the same time. And this was done, the Qt code was written by Evan, and Brian and I had support from Enthought to work on all of the backend and the protocol machinery that made that possible. And then after that, after the machinery for the Qt console allowed us to do the architectural decoupling that we needed, the sixth attempt at a notebook is finally what I am using. This is actually the fifth one. This is the only one that I could find a screenshot for. We didn't arrive at the notebook that we have today overnight. We had 5 failed attempts that came first, where we went down every conceivable dead end. We made every conceivable mistake. This was the fifth one, which was sort of the real precursor to the one we have now. It was a prototype implemented by James Gao, a grad student at Berkeley, based on an explanation of the protocol from the Qt console. And it was sort of the basic proof of concept that the protocol design that we had built up really did work. And after this came out, Brian was able to spend a summer of really hard work in building the first functioning version of the current one, which is, I don't have a screenshot because that is what I'm using. And then cool things began happening. The architecture proved itself to be sort of robust and capable of supporting a fair amount of weight on top of it. And then people began coming out of the woodwork. We gained this fantastic contributor, Matthias Buissonnier, who in 2012 built a website called NBViewer. He called it his weekend hack. And NBViewer is a website that allows you to share notebooks. So it's nbviewer.ipython.org, and it lets you put the URL of any public notebook, any notebook that's available on the internet, and it'll render it for you in nice HTML, which enables people to share what they're doing with notebooks without the need to install anything and without the need for the recipients to have anything, because this will produce a web page for any notebook. One of the most popular ones is due to the wonderful Jake Vanderplas, is how to do XKCD-style plots in IPython. It's part of his blog. This is the work. I'm sure this was part of the NSF grant that funds his work. Right, Jake? And then we've kept doing sort of trying to show that it really is possible to do the things I was talking about before with an integrated tool. So later in 2012, we were able to collaborate with some microbiologists, for example, in Boulder, and we actually ended up writing a paper out in effectively the work took a day, and a week later we had submitted a manuscript to a Nature microbiology journal called ISME that is accompanied by a collection of notebooks that replicate all of the results of the paper, all of the code, everything we did is contained in a set of notebooks that you can view here. This is a companion website with supplementary materials for the paper, and all of this runs on Amazon, doing a phylogenetic tree reconstruction analysis in parallel using Amazon. And not only did we publish the notebooks that are behind the paper, but we also published the StarCluster configuration. That includes the AMI identifier. So this is the Amazon virtual machine image on which we ran the computations. So anybody who wants to replicate exactly what we did simply has to copy this config into their StarCluster config file. Obviously, they have to add their own password and their own Amazon key because you have to pay for the Amazon service. But other than that, once they copy this and they initialize a StarCluster and they grab our notebooks, they will be exactly replicating a complete parallel, the entire parallel runs that we did to obtain the results in the paper. And then they can decide whether we did something right or wrong. They can build upon the work, etc. So we're trying to show that you really can go from all the way to publication, fully replicable computing, including large-scale parallel runs. To give you an idea, the serial version of what we were trying to do would have taken longer to do one single run than it took us to do all the trials, do the actual production run, write up the manuscript, and submit the paper. We did all of that in about a week, whereas it was about a month's worth of just raw computation if you had done it serially. So we think it shows that it really can be done. And a lot of communication today is not happening, a lot of interesting communication is not happening via papers, but it's happening on technical blogs. And we really wanted to show that it was possible to write blogs, write a full blog post that would include technical content as a notebook and use that as the base of the discussion so that if somebody wanted to comment on what you were doing, they wouldn't just argue about your plots, but they could grab your code, rerun it. And so we posted some examples on how to do that. And Jake Vanderplas, who has, if you don't follow his blog, you should, Pythonic Perambulations, has now a very nice pipeline for blogging where everything he does, all of his blog posts are written themselves as notebooks. So you can read his blog post, but you can run the code, and there's always a link at the bottom to download and execute the code. And he has really nice things like he's built things like Matplotlib-based scrollable animation viewers and things of that nature. I learn a lot actually by reading his blog. But every single blog post is actually a notebook, and the combination of his blog posts is obviously a GitHub repo on GitHub. So we're really trying to sort of enable the full spectrum of technical communication. That took us to the White House. None of us were invited, but somebody was. And if you watch, this was the first hackathon at the White House in March of this year. If you see here, you'll recognize, and I know Eric Hagberg is in the room, so he'll be happy to see that NetworkX was prominently displayed at the first White House hackathon in March of this year. And finally, to books. In a format that I'm calling literate computing, rather than in contrast to the classical term of literate programming. The model of literate programming that is kind of widely known in the technical computing community makes a strong emphasis on the creation of programs that are there, documents that are then turned either into other documents for human consumption or into programs meant to be executed at a later time. The workflow that we emphasize is the act of computing itself, where you are computing with objects that are alive in memory, where you're iterating on top of data and code that is constantly evolving, but you have a live computational state. And that is the process that we want to make literate. That is the process that we want to make more informed and better documented. So I don't like to use the word literate programming. I think the better description is literate computing. And now we have full-blown books written in this mode. Some of you may have already seen this one. For those of you who haven't, I strongly recommend it. Is Cam Davidson-Pillen by any chance in the audience? No? Okay, I haven't met him. He's a fantastic Canadian kind of statistician and Python hacker. And so this is the website for his book. And the book itself, I mean, this is kind of the nice rendered version, but each chapter in the book, each chapter is a notebook. So the entire book is meant to be written. So I just clicked on one of them to open it, and the entire book is written as a here we go, is written as a collection of notebooks. He did a lot of work on the typography to make sure that it would look a little nicer than the default typography. He also modified the defaults for matplotlib so they would look a little bit more elegant, a little bit more R-like. And so here we have an entire book which is fully executable. So this is, where am I? Here. So this sort of closes that loop, and hopefully I've shown you that it really is possible to try to bridge across these gaps that we have in the classical with a lot of the classical tools, and that there's a reason for why we do what we do, and that there's a reason for why we've spent so much time building this architecture, for why we've always resisted, for example, the demands, the sometimes strident demands to completely remove and separate pieces of IPython, because people said, wow, why do I need parallel computing in a shell? That doesn't make any sense. You guys are crazy. That's stupid. There really was a reason for doing these things. This architecture is something that we've put enormous amounts of time into. And so what we've done is we've really tried to think hard about what it means to execute code. What does it mean to have a stateful computational entity? And we've put communications around that, so that instead of the notion of typing and getting results and displaying results that you happen to have kind of in a REPL has been completely abstracted to work over the network with various pieces of zero-MQ networking machinery and whatnot. But once you have this notion of a kernel that can be controlled by clients, and clients can send them input that may or may not be attached to a keyboard, then this allows you many forms of work. So I've shown you the Qt console, you've all seen the terminal, this is happening in a web notebook, and as you already saw, all of these are driving the same exact kernel at the same time. And there are less traditional ways of using it, so we can use the notebook, the IPython machinery as a web service, but not as a notebook. So if you take the same exact pieces of code, you can build other interfaces. For example, this is using the exact same machinery, but now it's a JavaScript app that calls out with its own custom HTML. There's no notebook here. I can't type cells. I don't have a document. There's no file to save. But it's reusing everything else. This is a teeny bit of maybe 1 or 2 pages worth of Python code that reuses all the machinery, presents a different HTML frame, and sends controls back to the IPython kernel, which is in the background. With the same app, you can build instead something that looks like a notebook, but it's a one-cell notebook. It doesn't create anything else. You can just run a bit of code and get some output. And that's it. Oops. And that's it. That's all you get. There's no new cells, nothing else. And so, and yet this is using the exact same infrastructure. Let me just close in here so I don't have to page through as many. Oops. And we're going close here. And so we're pushing now beyond the Python language itself. For example, we have we have now support for Julia, and I know some of the Julia guys are going to be speaking later, so they remember when this happened. This started just a couple of months ago, but now, thanks to a lot of work that the Julia guys have done on their side, you can in Python, in IPython, you can load Julia support, and then you can run. This is a block of Julia that simply executes, can, for example, mix a call from Julia, the sine function. This is a block of Julia code where the sine function is in Julia, but this is the cosine function from NumPy. And in a single arithmetic expression, they're working on the same array. You produce a plot in Julia, but it's a matplotlib plot that comes back to the Python side. You can do all kinds. You can do all kinds of interesting and crazy things. This is a recursive Fibonacci implementation, but with a two-step recursion instead of a regular recursion, so that the stack is actually sort of a layer cake, where every step in the recursion crosses the language barrier. And so the Julia fib is implemented in Julia, fib2 is implemented in Python, and they call each other, and it works just fine. So it's a bit sick, but no one ever accused us of being sane. You can create a figure in Julia. Here, F is a matplotlib plot that was created in Julia, but then afterwards I can grab the variable F from Julia, so I call the Julia magic, and then I assign it to the Python F variable, and then continue annotating the plot object that was made on the Julia side of the interpreter back on the Python side. So we can do some kind of interesting things. The parallel machinery is something that, as I said, is worth mentioning. When we tried to cover it in our tutorial, Brian and I just completely ran out of time. It needs sort of its own space for discussion, so I won't have time to go into it in detail. But it's a piece of machinery that exposes these exact same interactive tools, but instead of one of them, you get N of them, and with lots of support for doing things easily and in a high level. You still get interactivity. You can open a Qt console into engine number 132. You can run this on a supercomputer. You can integrate it with MPI, and all of it can be controlled from the notebook, so that all of your computational nodes could even be in a supercomputing facility, and you're doing all of the interactive control and visualization from your laptop at home. We've done some great work with Chris Keys at the DoD, precisely on enabling these kinds of usage patterns and trying to simplify his life. This is a model that is not meant, we're not really pushing sort of into the math scale of gigantic machines. Right now there are some bottlenecks that makes this only feasible up to a level of a few hundred nodes. We can fix some of those easily to go up to a few thousand. We're not in the business of doing 100,000 node computations with Python. There are other bottlenecks there, but a lot of interesting science happens in the 2 to 4 to a few hundred node range. Not everybody has code that really does scale to 10,000 node, despite what you tell your program managers. I won't write on you. And we've tried to expose a set of APIs that make the system very, very flexible. As I said, I don't have time to go into it in detail, but we've paid a lot of attention to performance. All the communications are done in 0MQ with as little copying and as little pickling as we can possibly manage, and with high-level interfaces and high-level APIs that try to enable a lot of work, a lot of kind of everyday work patterns to be done easily. I have two demo examples that I might come back to if I have time, but I think I'd prefer to leave some minutes for discussion rather than running the clock to death, as I tend to do. We around all of these tools, we've tried to build an ecosystem that is healthy and dynamic, and I'm happy to say that the community has been amazing, and people are doing all kinds of interesting things. I already mentioned StarCluster, but it's worth highlighting it. Justin Riley at MIT has done an absolutely incredible job with making a tool that turns the Amazon EC2 machinery into something that is really, really convenient and easy to use and to deploy. And he's put explicit IPython support, so that when you spin up, that's what we used for this microbiology paper that I mentioned earlier. When you spin up your Amazon cluster, if you add 2 lines to your config file, then it comes up as an IPython cluster. All the nodes are running, and the head node is already spun up with a notebook. So all you have to do is wait a few minutes for all the nodes to spin up, and you log into the URL that it prints at the end. You just click on it, and you're logged into your notebook and controlling your Amazon resources. He's done a terrific job. Somebody who contributes a lot to IPython, we've never met him in person, in Japan, wrote a notebook client inside of Emacs. So if you're an Emacs person, by all means, I actually am an Emacs person, but I do use the notebook in the web browser, but I know people who love it. It is the notebook. You open a notebook file, you type, and plots come back. And this kind of, I think he uses a Lisp WebSockets implementation, believe it or not. But if Vim is more your thing, Paul Ivanov at Berkeley implemented a Vim client to control an IPython kernel. And Enthought, in their new Canopy product, this is really what kind of the motivation for Enthought, is my understanding, for supporting the development of the Qt console was really so that they could build this very modern and sophisticated new IDE that came out earlier this year for scientific work, which also has an embedded IPython in it. Emacs, Vim, new IDEs, and Microsoft, we've been collaborating with them, has also a set of tools for Visual Studio and support in Azure that include IPython. And this is a screenshot of the newest version, which I think is going to be released in a few days. And they sent me a couple screenshots so that now it has plotting inside the embedded IPython shell inside of Visual Studio. And this is interesting because they're not embedding our widgets. They're using the protocol, right? Visual Studio is not written in Qt. Visual Studio is written in whatever Microsoft internally uses to design their large-scale applications. But what they're doing is they're speaking the protocol. They're speaking the protocol, and then they're embedding everything in their own app. And now they even have some nice things that we were kind of crying about yesterday at the in-depth NumPy tutorial about the pain points of debugging, doing mixed language debugging, and they've added support for some of that. Continuum also now has a product that uses the notebook in the cloud called Wakari that I'm sure a number of you probably already use, that embeds the notebook in a web service that runs at Wakari on the Wakari domain. We recently found out about another company called iMath Research. This is just a screenshot from their website, but they also seem to be embedding, they're a Spanish company that also seems to be embedding the notebook in a web service. And at this point, it's really, I really want to spend some time emphasizing the fact that, as obviously anyone can imagine, this is not my work. At this point, I do very little. And the real talent and the real work is done by a fantastic team. Brian and Min are sort of the two people that have been with me for the longest, and they are the real brains behind a lot of this magic. It's not me anymore, and they are an absolute joy to work. But we also have a very talented team. Thomas, are you in the room? Did you make it already? Okay, so Thomas Clover, probably badly jet-lagged, arrived from the UK last night. Matthias could not come. Paul and Brad are at Berkeley. And Paul is here, Brad could not come, and we have Jürgen in Sweden, and Robert, Evan, and Jonathan, who are all three from Enthought. And a project like this is impossible without a good community. This cast is incomplete. I've listed here a few more folks beyond the core team, but at this point we have several hundred authors, and it would be impossible for me to go through the whole list. But they are the ones who are the real magic behind this. We've learned a few things in terms of community, and I'm sorry that I was so tired last night that I forgot to put a link that I wanted to put here to a very important paper that I strongly recommend you all read by Matthew Turk, who's in the room, called Scaling a Code in the Human Dimension, because it's a really nice and thoughtful analysis of these issues about the human side of building a computational community. It's a delicate balancing act where you really have to balance very, very carefully notions of allowing for individual leadership and ownership without creating turf wars. You want to have a clear vision of where the project is going, but you need to engage a community that brings new blood and new ideas. And a key element of that is learn and attempt and possibly fail to keep disagreement as the engine of creativity. But disagreement is a highly volatile and unstable fuel that can either lead to lots of good stuff or blow up your community. I think that's one of the things that we are good at in IPython, and it's possibly because we disagree a lot. Believe it or not, Brian and Min and I actually have incredibly divergent views on lots of stuff. but we're willing to wait first. We're patient. We trust each other. We trust that our disagreement is because we see a problem differently, and that means that probably neither of us has quite found the right solution. And we respect each other, and we treat each other with generosity to try to continue seeking what is the right answer to a problem until hopefully we come to some conclusion. And sometimes we're willing to make calls. At the end of the day, I try to wear that BDFL hat very, very, very lightly. I don't think I've ever made kind of a call that really makes any of us unhappy, but I think we're willing to make some calls sometimes. And if we make a mistake, that's okay. Well, there's no recrimination. We're all trying to do the best we can. And very importantly, these rules apply to everybody, starting with me, right? Even if they slow me down, I still have to go through a pull request. My code can still be denied admission by anyone in the project. That is very, very important because I think if we don't do that, we really hurt a project. Community engagement. We have a number of channels for trying to engage the community that are fairly familiar to all of you, so I won't go into detail. But one that I want to mention that is new is our new kind of lab meetings on air. Now that we have funding, there's a piece of IPython that looks a little bit like a more classic academic project with a lot of internal discussion. We have a big team at Berkeley, and Brian is very close by, but we wanted to not create the water cooler effect where these people talk a lot and can do a lot, but the external community is a little lost. So what we're doing now is we have our lab meetings as open hangouts in Google on Air. Anybody can join. They're broadcast in real time, and there's a chat room that is live available so that if you want to ask a question, you can ask it. And they remain, they're kept in YouTube on record. We have some funding now, as was mentioned earlier. Brian and I are co-PIs on a grant from the Sloan Foundation for 2 years. And there are two agencies whose names I can't put here because unfortunately these grants are technically ready, but until the checks are actually ready, I'm not willing to say that we have them, but in principle, we also have funding for reproducible neuroimaging data analysis and for time series analysis from two different agencies that was meant to be already in the bank, but isn't. We have received prior support. In particular, Enthought has been from day one, from the very beginning, the mailing lists for IPython have been hosted by Enthought, and they've been phenomenal with us. But Microsoft also has been supporting us for the last few years, and we have a great relation with them. And the DoD via Jose Pinco and Chris Keys, we've had some very productive work done with them, and we'd like to thank them. Very quickly, because I know that I'm running out of time. This is our quick view of our roadmap. We're going to try to get IPython 1.0 out in the next few weeks. In the fall, we're going to be working on something that we know all of you want, which is a clean way of having interactive JavaScript controls that goes back to a kernel, the kind of thing that I was showing with those sliders. But if you look at the code that does that under the hood, it's hideous. So we're going to try to think how to do that better. And next year, we'll be working on the design of a multi-user version of the notebook server that you can deploy at least in a cluster environment, in a Unix server environment with trusted users, in a lab, in a group, at a university, that kind of thing. A very quick plug, because you all have the program, I won't dwell on it, but there are 5 talks at least that are in one way or another that I know are about IPython during the conference, so obviously please go and see them. And while I take questions, I'd like to remember that a year ago, this talk was being given by John, and he's not with us anymore. Thank you.
Of time. We have 7 minutes for questions, so feel free to ask Fernando.
Aaron?
So on the slide that you skipped,
which one?
The one about community something or other.
If you can repeat the question, then
I will. I'll let him. I'm going to put that slide up. This one or this one?
The next one. So it says that you've got one project mailing list. I thought you had 2 project mailing lists. IPython dev and IPython.
Yes. So the question is for the recording that it says here. I say here that we have one mailing list, and he says we think we have 2, and so both are true. What I meant. Yes, we do have, there is IPython-user and IPython-dev, because that seemed to be the kind of the thing to do 10 years ago, 11 years ago, when Eric said to me, do you want Enthought to host a mailing list for you? And I said, sure, let's make a user and a dev list. But over time, we grew unhappy with that idea of separating into people into two buckets, users and developers, and we wanted to move towards kind of a notion of a stakeholder who one day may be a user, but tomorrow may be contributing. So now, the user list exists, and we try to answer, but we've removed all visible links to it, and we only publish the links to the dev list. So basically, the dev list is sort of the project mailing list. And if somebody asks a question on the user list, we'll do our best to answer. But we're trying to by simply publicizing only the dev list, have it be the list. We could have closed both and made a single IPython mailing list, but we decided it wasn't worth the hassle. Yes, question in the back?
Could you create an alias just the IPython list that points to the dev list?
Probably. Haven't bothered, but. Yeah, we probably could and we probably should. Yes, question?
You said you had to follow the same rules as everyone else. Have you enumerated what those rules are? You know, is there somewhere that says, you know, you must go through a pull request?
Yes, yeah. We have our developer guide. I mean, I don't want to go on the record with how clear it is, and we can look into it. But within our community, I mean, we're following kind of the standard process. You have to have a pull request. I mean, we really only push code straight to master if it's an absolute emergency, sort of brown paper bag, massive emergency. And Min actually does something great, which I every now I used to do that in an emergency, but Min actually has the habit, which I think is better, of even if he has to do something like that urgently, he'll make his own pull request and then he'll close it himself, so there's a record of that action. And so I don't know that we've codified that in as much detail as we should, and that would be a great PR to have. But the rules are, in the community, they're reasonably clear.
I mean, I guess the point is, do you need to enumerate that?
I think it's a good idea to have a process which is as unambiguously clear as possible for people. I don't think that's bad. I think it's just a matter of taking the time to do it. I don't know, Brian, do you remember how clearly we've listed that stuff?
We don't really cast it as rules, but more of here's what our development workflow looks like.
Mm-hmm.
There's a GitHub wiki page that describes that.
Yeah. Yes, I can't keep track. I think that hand went up first, and then we'll come here and there.
What has been the
Jason.
perception of IPython within the general community outside of Python users? You know, MATLAB users, or maybe Ruby or Java, just general computing?
So I don't really know too much about the MATLAB community. The R community has made a lot of progress in their own versions of similar tools. So even though they're interested, I think there's been less hands-on interest. The Julia guys, on the other hand, we've had great discussions with them. They were beginning to implement something that looked kind of like a notebook and their own terminal. And I think I managed to convince them that it would be better if we collaborated and that we would fix whatever wasn't quite right in IPython so that this was a wheel they wouldn't have to reinvent, and they could use the same notebook format. It's important to note that the notebook format itself has no Python in it. There's no Pythonisms in the protocol, in the format, the file format. So we really want the idea, and we almost have it working. I actually have a prototype where there's a native Julia kernel that almost works. Not just a magic, but a native Julia kernel. And Min wrote a Ruby one that works. I don't know how widely used it is, but it works well. And I see it pop up on Twitter every now and then. Recently, I saw a Clojure project on GitHub that was listing the notebook as inspiration, but it wasn't, and the architecture, but they were actually re-implementing their own thing. I think Java people love to do big networking libraries. So I think we're seeing some traction. Some of it is traction on the ideas, some of it is on the implementation, and that's what we're most excited about, is real reuse of the actual implementation so that we can share these documents, and the collaboration with the Julia team is one that has me very excited. I think Ben and Matt.
Maybe just one quick question. Go.
With development pace being as fast as it is with IPython, how do you guys keep up with the final end user documentation?
We don't.
Can you repeat the
With the rapid pace of development of IPython, how do we keep up with the end user documentation? And the answer is we don't. The community is doing a phenomenal job writing lots of great tutorials and great other things, and they're sort of patching up our deficiencies. I wish we were doing a better job, but we're not. So I'm going to be around for the rest of the conference. So rather than starting by breaking the schedule from the first time, let's let the organizers continue, and I'll be happy to continue chatting.